Okay, let's talk about working with units of measurement. Now we're in the measurement module, so we got to start thinking about when we run units of measurement through the four basic operations, adding, subtracting, multiplying, and dividing, how that affects the units. Now adding and subtracting is really easy. I'm not even going to do examples of those because they're so ridiculously easy. All they have to be is the same unit. So if you have like 2 feet plus 3 feet, you get 5 feet, just feet, okay? You can't add like feet and inches or gallons and centimeters, something weird like that. When you get into multiplication and division, that's when things change, okay? Now, I do have a math book that showed a pretty good example of this that I've liked, and I've always taught it this way. So when you look at this one, this first example, 7 times 7 feet times 6 feet. Now we're timesing feet by feet, okay? So the best way, when they broke this down, the best way you can think of this, or the way they explained it, is what you do to the units. So if I do 7 times 6, or what you do to the numbers, do the same thing to the units, and then feet times feet. So 7 times 6, pretty easy, 42. Feet times feet, well, another way we can express this is feet squared, okay? Or I guess if you want to be 42 square feet. I don't care which one you use. But we think about this, okay? Between the difference between a foot and a square foot is a unit of area, okay? And kind of think about what this means when you say you have 42 square feet. That means I have 42 1 foot by 1 foot squares. And what this means, like, if we actually draw out a square, maybe we'll do it for me. Okay, so that's the one time the shape recognition is useful. So, if we got, let's say, here's the 6 foot section, here's the 7 foot section. If I divide these up into 1 foot columns, let's see, go that way, 2, 3. Just imagine they're symmetrical. Let's see, 1, 2, 3, 4, 5, 6. And I do the same thing this way, 1, 2, oops. Okay, just imagine they're all symmetrical. I try to get it the best I can. But that means if you divide these up into 1 foot rows this way and 1 foot columns this way, if I counted up all these boxes, I'd have 42 of those boxes. That's what 42 square feet means. It's like literally just imagine you're throwing a grid across it, and the number you get tells you how many of those little squares you have in there. Obviously, they'd be square if I could draw straight. And the good thing about this is it doesn't change when you go to different numbers or different units. So 2 inches times 3 inches, that would still just be 2 times 3, and then inches times inches. 2 times 3 is 6, inches times inches, well, that's 2 of them, so that's inches squared, or 6 square inches. So anytime you take a unit times a unit, however many times you're multiplying it, that's what the exponent is. So 6 square inches means I have 6 1 inch by 1 inch boxes. Then what if we throw in another dimension right here? Let's see, so then we do the same thing. 4 times 5 times 6, and then inches times inches times inches. So 4 times 5 times 6, that gives me 120. Inches times inches times inches. Well, there's 3 of them, so that's to the 3rd power, or 120 cubic inches. Okay, so cubic inches measure volume, because you think volume, that's 3-dimensional, right? So, well, we have 3 dimensions right here, 1, 2, 3. Square units measure area, or 2-dimensional stuff, flat surfaces, 1, 2 dimensions, okay? So when you multiply the same units, they just get squared, okay? And you'll only do this with length. You won't be doing with like gallon, you won't be timesing gallons by gallons or anything like that, just units of measurement. So if we go down to the other operation we didn't talk about, division, this is where compound units come from. So again, in the same thing, if you follow that simple rule, what you do to the numbers, you do to the units, it gives a really good blueprint of where the unit you're left with comes from and what the number represents. So this one, they said 450 miles divided by 3.5 hours, or if you want to use the classic division symbol, you can do that. So we do 450 divided by 3.5, and then we do miles divided by hours. So 450 divided by 3.5. Pull out my calculator here. Let's do 450 divided by 3.5. So that gives me 128.57. Let's go ahead and just round that to let's do 129. Let's see. And again, if I want you to round a specific thing, I'll tell you what I want it rounded to. Miles divided by hours, we can't really do anything with these because they're not the same unit, so this just becomes miles over hours, or another way you can express this, if you ever look at your speedometer, you should know what this is, miles per hour. You think about it, that's really what we did, is we took the total number of miles divided by the total number of hours, and it averaged out to about 129 miles per every hour. Okay? So again, what you do to the numbers, you do to the units. So we go to this last example over here. This is probably the most tricky of the two because it plays with the fraction rules we talked about earlier. So 120 miles divided by 60 miles per hour. Now, with these ones, you'll probably never get the number wrong. You'll just get the units wrong. So we look at this one. We have 120 divided by 60, so that doesn't change. But then we have miles divided by miles per hour. So 120 divided by 60 is 2, but 2 what? So miles divided by, another way we can express miles per hour is right over here, miles over hours. Same thing, right? And if you look at this one, I know we're kind of going to a really, really abstract type of problem here. But we look at this, miles over hours, I'm taking a whole number divided by a fraction. Whenever you divide by any fraction, what's the rule? Flip the second one. So this will be miles times hours over miles. I guess you could put this over 1 if you want to be technical. But we look right here. If you remember the next step, and this is a rule I always tell people to remember for fractions. Same units diagonally, what do? They cancel each other out. So what am I left with? Just hours. So that is just 2 hours. Okay, so again with this one, the number part on this is not hard to compute. It's just getting the units right. And if you remember the simple rule, what you do to the numbers, you do to the units, you'll be fine. You won't deal with too many of these complex problems. I just want to kind of show an example of how we can apply the mathematical methods we've learned earlier to really different types of problems. Because, if you remember from the earlier videos, I always kind of, get on my soapbox about, don't just get the numbers to get the numbers, kind of look at the mathematical method in a broad spectrum and see where you can apply different things. And here's a perfect example of dividing fractions. I mean, even though we're not technically dividing numbers, the same rule still applied. Flip the second one, cross out what's similar diagonal, and what you're left with is your answer. Okay? So hopefully this gives you an idea of where the units come from and why they end up the way they do.